Hi everyone, welcome to another video on, this is a bit of a new topic. In this video, I'm not going to actually teach anything. Instead, I will be reviewing some of my books. So, we all know that to obtain knowledge, we could either discover things on our own or have someone teach it to us. And the second route is actually a pretty nice route of gaining knowledge, but the first route is also really nice. This is where textbooks come in, because textbooks, well, good ones, will teach you things, and they will also kind of nudge you to the direction to kind of discover things yourself. So in this video, I'll be reviewing some of my textbooks and kind of show how they've contributed to my overall knowledge on physics and math as well. So without any more further ado, let us begin. So my first textbook is called Guide to Linear Algebra by Ivan Savov. Yeah, Ivan Savov. I apologize for the profanity in the title. It's just there. But yeah, it's a guide to linear algebra. And this book was a really, really nice book. And I'll give some of the context on why I got this book. So I was in my freshman year of high school, and I wanted to learn quantum mechanics. I've tried learning quantum mechanics in 8th grade, and I didn't really learn it as much as I wanted to. And I learned that to understand quantum mechanics, I first needed a good foundation on linear algebra. So I got a linear algebra textbook. Well, by that point I've already seen some PDFs on linear algebra, so I already had a nice idea of linear algebra. But I actually got a textbook for myself. Now, this textbook on linear algebra teaches you linear algebra at the undergrad level, and it basically builds you from level 0 to an intermediate level on linear algebra. And in my opinion, everything in this book, it gives you enough knowledge to understand quantum mechanics. As in, like, it teaches you the linear algebra needed for quantum mechanics. Like, it gives you everything that you actually need. What I really love about this book is that, like many books, like in math, like, they have a lot of fluff in it. They don't get straight to the point, right? Like, they give like a big speech about like why things are the blah 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 blah, but they don't actually, like, it's really kind of rare where you find a book that just teaches you the math, like, just straight up, like, no like long derivations of anything. And this is a book that avoids that. This book gets straight to the point on linear algebra. There's no fluff in the book. It just, want to learn about vector spaces, it's not going to give you a long story on vector spaces. It's going to tell you what a vector space is. So it's really nice. It's very straight to the point. So it's really nice to just, like, get that knowledge quickly. Now, there is actually a good reason as to why many textbooks have fluff in them. That is because fluff gives you very nice intuition and motivation. So one could argue that it's a bit of a flaw in this book. It doesn't have that, like, motivation in things. But you could also argue that it's a really nice book because it's straight to the point. And that's probably where this no profanity word comes in. Don't want to get demonetized. But so yeah, this book is very nice. And the cool part about this book is that at the end of the book, it gives you applications of linear algebra. If you guys didn't know, probably should have said this earlier. Linear algebra is basically like the math that describes everything. This is a bit of an exaggeration, but, like, for physical things in the real world, linear algebra describes it. Cryptography, described by linear algebra. Economics, linear algebra. Modeling hurricanes, linear algebra. Pretty much everything that deals with material things in the real world can be and is described by linear algebra. So why is this? Well, many systems in real life can be approximated as a linear system. And linear systems are basically systems where, like, y equals mx plus b applies, to kind of simplify it a bit. And with linear systems, you deal with like vectors, matrices, operations, and stuff, which are very crucial tools to modeling real things. So many things in the real world require linear algebra, a very decent understanding of linear algebra, and this book gives you that understanding. And it gives you applications of linear algebra, because oftentimes when we're reading like a math book, like this is a math book, by the way. So when we were reading a math book, we oftentimes just get like kind of lost, like, why are we learning this? Like, you're like topology class and you're like, gosh, why am I learning about cohomology? Like, why? Cohomology is so abstract. Like, what's the use for it? So oftentimes, like, we need a reminder on why we're learning something. So this book gives you applications of linear algebra for many topics at the end. It gives you applications for quantum mechanics. That's like a really big thing. It also gives you applications for for computer science and some other things that I forgot. So yeah, it gives you applications. So yeah, that's pretty much this book. If I would rate it out of 10, I would give it a, well, I should really just rate it for like each like aspect of like textbooks, but in the general sense, I'd give this book a nice 7 out of 10. It's a really nice book. Okay, so about my other books. Well, when you all start learning physics and math, you rarely ever start from textbooks. If a kid knows nothing about physics, if they're not naive, which, well, they will be naive, they're not going to start learning from a textbook. Instead, they're going to start learning from a source that is, well, intended for them. And a very, very nice book that gives knowledge of physics to the layman is Stephen Hawking's famous book, A Brief History of Space. I know it's a brief history of time, but I just like saying brief history of space, like kind of throw people off. But yeah, it's a brief history of time. So this book is a really nice book for, like, if you don't know physics at all, read this book. This book is not intended for the undergraduate student. It's intended for like someone that's just interested in physics, that just knows conceptual things and wants to learn more conceptual things. This book is really nice. I'm doing that. Includes new material. Ooh. I got this book in I believe how old was I then? Well, at the time I was learning the Maxwell equations. So I think this was about like 4 years ago I got this book. So it's really old. Yeah, it's a really old book that I have, but it's a book that I treasure because it actually teaches you the conceptual physics. And when we try to explain physics to like laymen, it's pretty much inevitable that we oversimplify things. But I think this book does a really nice job of kind of like it does oversimplify things, but it tells you if it's oversimplifying something, and it tells you how it is being oversimplified. So you kind of know like which parts are like kind of wishy-washy and which parts are more concrete. That's what I like about this book. So you can see this book over here. It has many diagrams. You have chapters. Like, it talks a lot. Like, a big part of this book is time. Hawking likes talking about time. So he talks about like the era of time, like how time originates, cool things like that. He also talks about Hawking radiation. Kind of one of my only criticisms of this book is in Hawking radiation, it gives you a simplified view of it, and a bit too much simplified for my liking. So he talks about how Hawking radiation can be described by entropy and virtual particles and stuff. But really, virtual particles, their existence is questionable. Now, if you ask any physicists about virtual particles, if you ask them if they're real, we're gonna have a big fight at the end. But basically, their existence is questionable for a number of reasons. So one of them is that they only exist in perturbation theory. Take the Dyson series, and each of the terms are like the virtual particles in a way, and yeah, they exist in like I don't want to get too much into it. This was not a teaching video, but basically, virtual particles like their existence are like they exist in perturbation theory, and they appear when we try to make approximations to things. But they're very useful tools. But Hawking explains configuration with virtual particles, which isn't the actual way how it works. It's a simplification. But the real way is that you consider the field, the quantum field, like before the black hole is created, right? And then you consider the field when the black hole is created, and the field like inside the black hole, like it's actually cut off. Like events in black holes are cut off from outside events. It's like light can travel, right? So the field inside the black hole is cut off from the outside field, and that ends up creating particles. That's like the real explanation of it. But the virtual particles explanation of it is like probably good for the layman, but I think it's a bit too much. Because like there's a lot of like, I don't want to get too much into it, but yeah, that's Hawking's book. A really nice book. I really like the cover, how it looks. I rate this book for the layman. This book is like a nice 8 out of 10, 10 out of 10, 6 out of 10. It's really nice. Okay. Here I have a book. This book is for the layman, but a bit higher level than Brief History of Time. It's called QED, Strange Theory of Light and Matter by Richard P. Feynman. So, Brief History of Time, I got that book when I was 12 years old. This book, I got it when I was 13, I think, 14. So yeah, so like 2 years ago. So it's a bit old, but and I actually didn't really get much. I didn't really like see much of this book. I got it, so I was like, oh, I like Feynman, right? But I didn't really get much into this book. Like a big part of this book is explaining how photon scatters, and it talks about the philosophy of it as well. Like how does a photon know to scatter in this way? And Feynman says, well, physics doesn't answer that. So the question is for philosophers, right? So I like how he touches on the philosophy, on like how and what we are doing when we model the universe. Like, is the universe the way it is because we modeled it that way, or do we just model it the way it is, right? For me, I prefer the latter view of like how science works. But yeah, it's a really nice book. I didn't really get much into it, but like, as you can see, a big part of this book is about how photons scatter. Here, it's talking about the path integral formulation. Like we have a slit, and wait, is this the path integral formulation? Is that what it's talking about here? I think it is. Like you have like an infinite number of slits and stuff. So yeah, it's a really nice book. It talks about time, time's a big concept of physics. So yeah, I didn't read much of this book though, so I can't give a solid ranking. But so far, reading it, I'd give it a nice 7 out of 10. And here is the big boy, Griffith's Quantum Mechanics. This is the book that has caused me a lot of depression. I'm just kidding, but now this is like an actual textbook. It's an undergraduate level textbook. Now the funny thing about Griffiths, it teaches quantum mechanics, by the way, intro level quantum mechanics. This book is not for the layman. Right, just opening this book. This book is it's not for like a layman that doesn't know calculus, that doesn't know linear algebra. Yeah, so this book is intended for the undergraduate physicist, second or third year undergrad. And this book, like the funny thing about Griffith's Quantum Mechanics is that like everyone likes to hate on Griffiths. They all like to say, oh, Griffiths, blah blah blah, it's just expressions are trash, not enough content, and I just I just ignore the haters pretty much. Like Griffiths, like there are a lot of places where the book falls short. But like it's a really nice book. Cause like, well, I know quantum physics like before this book compared to after I read this book, but I didn't read all of it yet. But it's like a lot, right? So this book will teach you many things. So people like criticize it because it's not Shankar, it's not Sakurai, but the book doesn't intend to be Shankar. It doesn't try to be Sakurai. It tries to be a book that lets you, that takes a person that knows nothing in quantum mechanics and molds them into a person that can eventually read Sakurai and can eventually read Shankar and get an even greater knowledge on QM. But yeah, this book is like, it's no baby, right? It teaches you spin. Like chapter 4 talks about like spin, spin matrices, polygon spin matrices. Yeah, again, my knowledge in QM mostly comes from this book. Like when the videos I actually on quantum mechanics, I actually like made those videos. Like it's just a nice story. Like when I was starting out in quantum mechanics, I didn't really like have there weren't really much videos to like talk about like quantum mechanics at this detail, at like this rigorous level. And it was like there's a channel called Brent Carlson that like made many videos on quantum mechanics, but he just stopped. So it made it harder for me to learn the concept because there weren't many videos there. So now I got Griffiths. I've read a lot of Griffiths, and I'm like, okay, well, I'm at the position where I can be the person that I wanted to exist when I was starting Griffiths. When I was starting quantum mechanics. Like I can actually make videos to teach people quantum mechanics because so that like they can be able to watch videos when I couldn't. Like that was a big struggle of mine. And now that I'm able to like make other people not have that struggle, well, I'll do that. I'll make their lives easier. So like I wanted to be like the person that would have helped my past self. And that's a big motivator for me making these videos. Like just to help the undergrads out there confused about life, be able to pass their exams, and just like enjoy physics as a whole. So yeah, just like, and these videos like help me as well. Like when I explain a concept, like, it makes me understand them. It makes me understand the concept. I'm just a tad bit better. So yeah, that's the a big reason why I make these videos. So Griffith's really nice. Chapter 4 though, it's really daunting. A tip for those that study quantum mechanics is that first of all, don't be naive. Like I remember when I was like 13, I was like, I'm gonna learn quantum mechanics. Let's go. I opened Griffiths, PDF of Griffiths. I was like reading. I was like, this makes no sense because I didn't know linear algebra, right? I didn't even know Calc 3 at that time. Well, I did know some partial derivatives, but like not like not the whole grand thing, right? So don't don't try to jump in the ocean before you learn how to swim. So it can be very, very frustrating. You're like, oh, I just want to learn quantum mechanics. Like it's cool, like all the cool concepts in it, like wave function, what does that mean, philosophy and stuff. But you need to know linear algebra, which is why we have this book. You need to know the prerequisites, right? But once you know the prereqs, this book is going to be very nice for you. But you also form study groups. So when I was like reading Griffiths, I was like, okay, good, this is pretty nice, but but motivation was a thing that kind of lacked for me, only a tad bit, because when I was like first studying Griffiths, I liked it, but like sometimes like there were those problems that just kind of killed you. Like it made you feel like you just wanted to jump off a cliff, right? And like it's nice to have other people that are doing the same thing as you to motivate you. So that's why I formed a study group. Maybe some people of that group is watching right now. If so, hello everyone. But yeah, that's why I made a study group. Study groups can like be really nice and motivate you, ask them questions and stuff. Like honestly, I wouldn't be this far in my book without my study group, to be honest. Like they're really awesome people, really interesting, awesome people. So yeah, just get a study group, get people to motivate you in learning stuff. The Aron of Bohm effect is shown here. Well, where like the magnetic field 0, there's still some cool effects going on. Like, yeah, just like really cool things in this book. This book teaches you, I forgot to say what it teaches you. It teaches you Chapter 1 is about like probability statistics. Chapter 2 is about like the wave function. Chapter 3, formalism, quantum mechanics. Chapter 4, the devil chapter. That chapter 4 gives me PTSD. Chapter 4 is about like spinners. It's about sugar increase in 3 dimensions, solve for the hydrogen atom, all that good stuff. Electromagnetic interaction and quantum mechanics. Chapter 5 is about identical particles, multiple particles. Wave function describes all of those particles. Chapter 6 about symmetries and conservation laws. You just like, and the rest is like history, right? And then chapter 7 and so on. They focus on perturbation theory. So yeah, that's Griffith's quantum mechanics. And yeah, those are. I have more books, but those are some of my books. I also have another book called I have some bachelor books that like like that I read when I was like really little, and yeah, they taught me like a lot about like the baby concepts of physics and so on. But yeah, like there are more books that I want to show you guys, but I'm running out of time right now. So I hope that. Oh, I forgot to review Griffiths. Shoot. Now, if you ask some like guy that knows quantum mechanics to review Griffiths, they might give it like a 2 out of 10. But I give Griffiths a 9 out of 10. No, 9.5 out of 10. I'm really thankful for Griffiths for like helping me a lot in quantum mechanics. So yeah, that is the end. That concludes this video. Hope you guys enjoyed it a lot. Yeah, I hope you guys rate this video a 10 out of 10. Maybe consider sharing this video. So yeah, that's pretty much it. In the next video, I'll talk about, well, who knows? We'll see. See you guys later, as always. Bye!